Okay, in this video I want to go ahead and go over the Pythagorean theorem, and then we're also going to look at its converse. Pythagorean theorem is something you should have seen before. Okay, hopefully this is just a review. I just want to make sure we cover it well before we continue on to some other stuff because we're going to need to use this. So first of all, the Pythagorean theorem applies to right triangles only. And remember, a right triangle has a 90-degree angle. The side opposite the right angle is called the hypotenuse. The other two sides are called legs. Okay, basically here's what the Pythagorean theorem says in words. The sum of the squares of the legs equals the square of the hypotenuse. Basically, what that means down here, this is what we care about. Okay, so if I have a right triangle, which it's not marked here, but here's my right angle. If I square both legs, a squared plus b squared, and add them, it'll equal c squared. Okay, so we're going to start. I'm going to go ahead and find missing side length of a triangle. I guess I better take a step back. When we're labeling A and B, it does not matter which side's A and B. It could be either of the legs. If I really wanted to, this could be B, this could be A. Okay, it's already labeled for us though. So I'm going to come down here, example 1. We just want to find the value of the missing side here, x. Okay, so in this case, we first of all want to identify what our C is. So this is my C because it's opposite the right angle. So the 7 and the 6 have to be my A and B. So I'll do A squared plus B squared equals C squared. So I want to say A is 7, B is 6, and we're looking for C. So if I do 7 squared, I get 49, plus 36 equals C squared. So that looks like it's going to be 87 equals C squared. And the last step, all we got to do is take the square root here. So I'm going to use my calculator and go ahead and find the square root of 87. My calculator is spitting out an answer of 9.33, we'll call it. 9.33, and that's if I go 2 decimal places. Okay, so the length of the hypotenuse here is about 9.33. Now it is important to note when we find the hypotenuse, it always should be the longest side. It's opposite the right angle. So a real quick check, I could verify that, yes, this is longer than my other two sides. Okay, continuing on with the Pythagorean theorem. Got another example here. Okay, find the length of the missing sides of the triangle. Okay, so on this side, first thing I want to do is identify what is my hypotenuse. So across from the right angle is my hypotenuse. So this has to be my C. Okay, so again, my A squared plus B squared equals C squared. Okay, A and B, doesn't matter which we call A and B. I'll say this is A and this is my B for my formula. So I could do 24 squared plus x squared equals 26 squared. So here I could square those numbers. If I do 24 squared, I get 576. I get plus x squared equals, if I do 26 squared, I get 676. Now here we got to do some algebra steps to solve. So I first of all need to subtract the 576 here from both sides. And so now I get x squared equals 100. And last thing we got to do is take the square root. So I end up getting x equals 10. Okay, so in this case, because we were looking for my A or B, we actually had to subtract these numbers. And I want to say here my x, my missing side, was 10. Okay, and we can see that the 26C is in fact my longest side, so that checks out okay. All right, this next question it's actually going to take us a couple steps here. Okay, I want to go ahead and find the length of AB. Okay, so I have a right triangle there, so I could say, okay, well this is my hypotenuse, so I could call that my C. And I could do A squared plus B squared equals C squared. The problem is I'm missing two sides of the triangle. So what I'm going to do is I'm going to go to this other triangle here. I could do, this is my C for this triangle. I could do A squared plus B squared equals C squared. And I could first of all find this side. Once I know that side, I could do Pythagorean theorem again to find the side I want. Okay, so I'm going to call this A here. So I could do A squared plus B squared equals C squared, with my 5 being C. So A squared is what I'm looking for, plus 3 squared equals my 5 squared. So a squared plus 9 equals 25. Subtract the 9 here from each side, so a squared equals 16. And when I take the square root to finish this, I get a equals 4. So now I know in my diagram this side has a length of 4. So I'm still looking for this segment here, AB. So I could do my side squared plus side squared equals my hypotenuse squared. So 7 squared plus 4 squared equals my hypotenuse squared. So here I get 49 plus 16 equals c squared. So I'm getting 65 equals c squared, and I take the square root. Square root of 65. My calculator is giving me an answer of about 8.06. So we'll say C is 8.06, which was what we were looking for, the length of segment AB. So segment AB has a value of 8.06. Okay, now we're going to move on to the converse of the Pythagorean theorem and another couple theorems to go with that. Converse of the Pythagorean theorem just means the reverse, okay? It just says if the sum of the squares of the smaller two sides of a triangle are equal to the square of a larger side, then the triangle is the right triangle. What that means, if I draw a triangle here, I say this is 6, this is 8, this is 10. I want to know, is this a right triangle? Well, what I could do is I could take the square of the smaller two sides, 8 squared plus 6 squared, and I want to see, I want to put an equal sign there, but I want to put a question mark above that. I want to see, does that equal 10 squared? If it does, if I do a squared plus b squared and it equals c squared, then I do in fact have a right triangle. So here I'd get 64 plus 36 equals 100. That is in fact true. So I could say with certainty that this is a right triangle. Okay. Now what happens if we take the the longest side and square it and they're not equal? Okay. Well, we have two theorems to cover that. We could actually determine whether it's an acute or obtuse triangle. So if I do my a squared plus b squared and that happens to be smaller than c squared, so meaning c squared is greater, I get an obtuse triangle. Remember, an obtuse triangle is just a triangle that has one angle that's bigger than 90 degrees. Okay? Now, if I square the longest side of a triangle and it is less than the sum of the two smaller sides, then I have an acute triangle. Okay, so let's just go ahead and try and do a couple practice ones here. I want to determine, is this acute, obtuse, or right? Okay, so what I want to do is I want to take the longest side, 10, square it, and I want to compare that. I want to see, is that greater, less than, or equal to 5 squared plus 7 squared. Okay, so I'm just trying to determine which it is. If the larger side squared is greater, we have obtuse. If the larger side squared is less than, we have acute. And if they're equal, we have the right triangle. So if I do 10 squared here, I get 100. Here I get 25 plus 49, which is 74. So I get 100 over here, 74 over here. So 100 is obviously greater than 74. So since my larger side squared is greater, I have a greater angle, an obtuse angle, okay? So this would be an obtuse triangle. All right, let's try another one. I'm going to decide, is this obtuse, acute, or right? So again, I'm going to take the longest side over here, I'll square it, and I want to compare that to 9 squared plus 10 squared. Okay, so if I do 13 squared here, I get 169. Here I get 81 plus 100, which is 181. So now I just got to compare these. Is 169 greater, less than, or equal? Well, it's less than. So since my longest side squared is less than, I have an acute triangle.